Welcome to AP Bio, and today we are learning about carbs and lipids.
There we go. We found a good role for you in this class.
I'm a YouTuber. What can I say?
All right. So today we're going to start learning our first group of macromolecules. All right. So when we talk about macro, right, we're talking about large molecules. These are the large molecules that compose our diet. Right. So today really begins our nutrition talk. All right. And to me, understanding nutrition, understanding what you're putting into your body is really important for the quality of your life, right? You are what you eat, right? When you consume food, you use that food for energy, and you also use your food for growth and repair, right? So the food that you consume will be broken down and literally used to rebuild your own parts of the body. Right? So it's really, really, really important that we have a good understanding of nutrition, of the food that we're putting into our bodies. For each type of macromolecule, whether it be a carb, a lipid, a protein, nucleic acid, whatever it might be, we're going to be looking at monomers and polymers. Right? Monomers are building blocks. Right? Mono, single. Right? They are the building blocks that are going to compose a polymer. A polymer is made up of many monomers put together. So most big molecules are going to be polymers. Now, no matter what type of macromolecule we are learning about, two things are going to stay constant, always. They are always broken down through the same reaction. They are always put together through the same reaction. When you want to make a bond, you are going to release water. Right? The release of water we called what just before? Dehydration. Right? The removal of water. Dehydration synthesis. And this is where your functional groups start to come into play. Because you have the hydrogen of one monomer and a what of the other? What's the OH called? Hydroxyl of another. Right? The hydrogen plus the hydroxyl are going to combine and form water, and a chemical bond is going to be formed. Right? Bonds are formed through dehydration synthesis. Right? I automatically go to taking amino acids to build your muscle proteins. This is the reaction that you would use to build muscle proteins. To break a bond, we're going to add water, and we call that what? Hydrolysis, right? Hydro, water, lyse, to break or to split, right? So essentially the exact opposite reaction is taking place. You are using the addition of water to break chemical bonds, right? Think about the process of digestion. I think about breaking down glycogen, something that we'll learn about today. Right? These are all good examples of hydrolysis. These are the only two reactions that we see. If two things are reacting, you're really only doing one of two things. That's all you could do. You could break a bond or you can make a bond. That's it. So you're either performing dehydration synthesis or hydrolysis. Right? Really the only two chemical reactions that we are going to see in this entire course. So when we look at organisms, right, there's a wide diversity of macromolecules. Macromolecules are going to vary from cell to cell. They're going to vary from organism to organism. They're going to vary from species to species. Right? There's an immense variety of different polymers found in nature. So our first macromolecule, the one that composes a bulk of your diet, is going to be the carbohydrate. Does anybody know what percent of your diet is actually supposed to be carbs? Never mind muscle and fitness and men's health and all that garbage. What percent of your diet do you think is supposed to be carbohydrates? Go ahead.
65.
Yeah, that's a good guess. Yeah, 60 to 70%. Right? Traditional nutritionalists, maybe 20 years ago, would say 70%. Right? I'd say closer, my opinion, closer to 60%. So, Ellie pretty much hit the nail on the head. All right? Somewhere between 60 to 70% of your diet is composed of carbs. Right? A lot of people will tell you that carbs are evil. Is that true?
No.
Absolutely not. Right? They should make up a bulk of your diet. What is the purpose of a carbohydrate? They provide what? Energy. Right? So carbohydrate is the preferred fuel to enter cell respiration. And during cell respiration, carbs are broken down to make what energy-rich molecule in your body? No. ATP. Right, ATP. ATP is your body's only energy molecule. Right? It's the only molecule that could actually power anything. So the reason why we consume carbohydrates is we break those carbohydrates down in order to make the ATP that powers everything in our body. So what's the name of the reaction that is going to break apart a carbohydrate? Hydrolysis, right? Hydrolysis breaks bonds. And when you break bonds, you release what? You release energy. And the energy released by breaking bonds is used to generate what energy-rich molecule in our body? ATP. Right? This is the purpose of consuming carbohydrates. Carbohydrates enter cell respiration. During cell respiration, carbs are broken down through hydrolysis. You break the bonds, you release the energy. The energy released is used to make ATP, your body's usable energy source. So if we examine carbohydrates, the monomer of a carb is called a monosaccharide. Mono meaning one, saccharide meaning sugar. Right? A single sugar. Monosaccharides are going to give you the most immediate source of energy. Why do you think monosaccharides are going to give you the immediate energy? Go ahead, Ellie.
To take less time to break down.
Yeah. They take no time to break down. Because they are already a monomer, right? Are you breaking anything down through hydrolysis? No. Right? It is already the monomer. It is already a single unit. So monosaccharides give you the most ready form of energy. They could be used immediately because they don't need to be digested through hydrolysis. There are some different monosaccharides that you should know. The most important monosaccharide is going to be glucose. Right? Glucose is a monosaccharide. It has the molecular formula C6H12O6. So when you look at the formula for a carb, it's always a 1-2-1 formula, right? CH2O. So it's C6H12O6. That is glucose. Now there's another one that you've all heard of called fructose, right? You've heard of like high fructose corn syrup?
Yeah.
Which is C6H12O6. has the same formula, right? How would you describe glucose and fructose? They're isomers. They're isomers. They have the same molecular formula, but they have a different arrangement of atoms. Which one of those two do you think our body prefers? Glucose. Do you think our body likes fructose much? No. Right? One of the issues with high fructose corn syrup. We're also going to see one called ribose. Right? Ribose is found in RNA. Deoxyribose is found in DNA. It is C5, so they would be H what? 10O5. Right? So these carbs always follow a 1 to 2 to 1 ratio. Glucose, fructose, ribose, these are all examples. Dextrose is another one of monosaccharides. You should always be able to identify glucose, because if you look at the structure of glucose, it is shaped like a hexagon. Right? Glucose is really easy to identify. A lot of people will tell you that simple sugars are really bad for you. Consuming things with simple sugar, things with glucose, fructose, ribose. So, is that necessarily true? No. The issue is situational, right? So, I get up early in the morning to work out. Right? I get up at 4:30, get to the gym at 5. Sucks, right? But what type of carbohydrate do you think would be the best for me to consume right before I work out? Something that's rich in what? Monosaccharides, right? Monosaccharides. Why? Because it gives me a really ready form of energy. Those monosaccharides, that simple sugar that I'm consuming, it doesn't need to be digested at all. It doesn't need to be broken down. It can be used immediately to power my workout. Does that make sense to all of you? Does it make sense to consume monosaccharides right before bed? No. Because the problem with ready energy is if you don't use it right then and there, what do you tend to store energy as?
Fat.
Fat, right? Fat and other things that we're learning about, right? So simple sugars are not bad for you. It's just that if you're not using those simple sugars correctly, then you're going to store that excess energy as other materials like body fat. So sugars are not the devil. They're just, you need to pay attention to when you're consuming them. Now, if you put two monosaccharides together, you create a disaccharide. How would you put two monosaccharides together? Through a bond. What type of reaction? Dehydration synthesis, right? There are a couple of different examples of disaccharides. Maltose is one of them, but one is super important that we always see, and that is going to be sucrose. Sucrose is made up of a glucose and a fructose, right? Glucose plus fructose make sucrose. And sucrose is table sugar. Right, it's what you would put in your coffee or something like that. Is it still pretty ready energy? What do you think? Yeah, because you only have a whopping one bond to break, right? So it is pretty immediate. Not as immediate as glucose is, but it's a readily available form of energy. Do that at home. Right? So sucrose, table sugar, is still short-term energy. Not quite as much as glucose, but it's still a readily available form. Now, when you put two monosaccharides together through dehydration and you make the bond, that bond has a name. It is called a glycosidic bond. You need to know that. So glycosidic bonds exist between monosaccharides. Right? They exist within sugars. Glycosidic bonds. Do you see how this one says a 1,4 glycosidic bond? And this one says a 1,2 glycosidic bond? Can anybody guess as to what those numbers are? What do those numbers mean? Any guesses? This one says 1,4 glycosidic bond, and this one says 1,2 glycosidic bond. What do you think, Joe?
Maybe it's because I may be wrong, but it's how many electrons are being shared between the oxygen.
It's a good guess. It's not that complex. It's the number of the carbons. All right? So this is carbon number 1 of this one, and this is carbon number 4. So it's 1, 2, 3, 4. So it's a 1,4 linkage, where this one is a 1,2 linkage. Not important, right? What you should know is that the bond between or within carbohydrates is a glycosidic bond. So you have monosaccharide, you have disaccharide, and now when you have many monosaccharides together, now you have a polysaccharide. And when I say many, I don't mean 5. I mean you can have hundreds of monosaccharides glycosidic bonded together. So large molecules. Now these polymers, these polysaccharides, they are used for long-term energy. Right? They provide long-term energy. Bless you. They could be used to store energy, or for many organisms, they are actually a structural component of that organism. Plants store energy as a polysaccharide called starch. So we often consume starchy foods. What are some foods that are rich in starch? Potatoes. What else? What did you say? Pasta. Yeah. What else? What are some foods that have complex carbohydrates that are starchy? Bread, pasta, rice, potatoes. All these things that we consider to be complex carbs, right? Are they going to provide you with short-term energy or long-term energy? Long-term energy, right? Because what do you have to do to all of those bonds? You have to digest them or break them through what chemical reaction? Hydrolysis. And that takes time. So since a polysaccharide needs to be broken down systematically through hydrolysis, it provides long-term stable energy. So if you're getting ready for a football game, right? What kind of carb would you want to have the morning of the football game, right before it? What did you say, Tess? You want to have sugars, monosaccharides, right? They're going to give you that immediate energy that you need for the football game. What do you want to have the night before? Polysaccharide. You want to have something starchy like a pasta the night before to give you that long-term sustained energy. Carbohydrates are not bad. It's a matter of knowing when to eat the right carbohydrates for the situation. Right? Polysaccharides like starches are going to give you long-term sustained energy. Monosaccharides are going to give you short-term energy. We actually store energy as a polysaccharide. This is one that a lot of people don't know about that I think is so important, called glycogen. Some people will call it glycogen. Some people will call it glycogen. Tomato, same thing. It's a polysaccharide, made up of an extremely long chain of glucose, glycosidic bonded together. Now there is a big misconception that a lot of people have. People immediately say, if you consume more energy than you use, you store it as what?
Body fat.
As body fat. That is not true. Before you store energy as body fat, you store it as glycogen. Glycogen is made in your liver and it's stored in your muscles. And within our muscle, we have like a glycogen tank. So if you consume more energy than you need, you convert the excess energy into glycogen. And that glycogen gets stored in your muscle tissue. Once your glycogen tanks are full, then you start to store energy as what? As fat. So first you store excess as glycogen, and then you store the extra as body fat. Does that make sense to you? Have you ever heard of a marathon runner hitting the wall?
Yes.
You ever hear that term?
No.
It's supposed to be extremely painful. It happens at about 2 hours into a marathon, typically 2 to 3 hours. And a lot of marathon runners quit because it's very painful. When you hit the wall, that is when your body is converting from glycogen to body fat as an energy source. So most of us, when we exercise and we do ordinary stuff, no matter how hard you're working, you're not working off of body fat. You're working off of the carbohydrates that are within your bloodstream, the glucose in your bloodstream, and the stored glycogen that you have in your muscles. It takes a lot of work to dip directly into body fat stores. Does that make sense to you? A lot of people are like, I burned 1,300 calories, I must burn some fat. No, not even close. Right? Not even close. You're working off of the glucose in your blood and the glycogen stored in your muscle tissue. Does that make sense? Right? It's the physiological effects of exercise and how it changes the efficiency of your body that then causes you to lose body fat as a result. All right. Here we have some structural polysaccharides. The major structural polysaccharide in a plant is called cellulose. Cellulose is to a plant like bones are to a human, right? Cellulose is a polysaccharide that gives a plant all of its structure. There is something really interesting about cellulose. Cellulose is made up of a long chain of glucose bonded together. Starch is made up of a long chain of glucose bonded together. They are made up of the exact same thing. Starch, we can digest. Cellulose, we cannot break down. Does anybody know what we commonly call cellulose in our diet? Fiber. Fiber is cellulose. A lot of people will tell you that protein is the most important component of your diet. They don't know what they're talking about. The most important component of your diet that most Americans are lacking is fiber, cellulose. You're supposed to get between 25 to 30 grams of fiber a day. Most Americans get around 3. I'll tell you why it's so important. But first, let's look at the structure. Now, Shaylin, looking at this picture here, both are long chains of glucose. Do you see that? What is the difference between starch and cellulose looking at the bonds?
They're in different spots.
They're in different directions, right? Do you all see that? See how this bond is going down and this bond is going up? right? The bond that is going down. We call this an alpha glycosidic bond. And we're able to break down alpha glycosidic bonds. That's why we can break down starch for energy. Cellulose, aka fiber, is going up. And we call this a beta glycosidic bond. We cannot digest beta glycosidic bonds. We cannot break it down. Isn't it kind of weird that the most important component of your diet is something that you can do nothing with, that you can't digest? You eat cellulose and you poop cellulose exactly the same. So why is it so important? What I'm about to tell you is a little bit gross. So if you don't have enough fiber in your diet, this is what happens. In your intestines, especially your colon, all your waste, all the undigested food, all the bacteria that builds up in your colon, that all starts to collect. And it starts to line the ends of your colon. Your colon gets thinner and thinner and thinner because it's just lined with literally crap, right? Before it exits your body. Then you go and you eat a Fiber One bar. And that Fiber One bar is full of fiber. And that fiber doesn't get broken down, goes into your colon, cleans all of that crap out, right? That is why people that if they don't eat fiber on a regular basis and they eat something really rich in fiber, they have to run to the bathroom because that fiber is clearing out their entire digestive tract. It's clearing out all that dead bacteria and waste food that was just sticking and collecting to the sides of your intestines. Pretty gross, right? Now here's the thing, right? If you don't eat any fiber and you eat fiber, that happens. But if you eat more fiber on a regular basis, it'll actually do the opposite. It makes you more regular because your digestive system is running clean, right? Your colon is not having all this bacteria and stuff collecting on the inside of it. Everything is cleaned out, right? I always tell clients, increase your fiber, you'll decrease your body fat, right? It'll make you leaner because it'll make your digestive system work more efficiently. You'll be better at pulling nutrients out of your food and better at eliminating waste. It makes a lot of sense, right? Fiber also makes you feel full because you don't break it down. So you tend to eat less when you have more fiber in your diet. Kind of cool. What are some good sources of fiber? What do you guys think? Do you not want to answer or do you not know? You guys know so little about nutrition? Joe, good source of fiber.
Almonds?
Nope.
No.
Grass.
Avocado? No. Grass, yes, would have good fiber, but most people don't consume grass on a regular basis. All right? Things that are whole grain, whole wheat. You know, when you look at the difference between like white bread and whole grain bread, white pasta, whole grain pasta, white rice and brown rice or wild rice. When you eat anything that's labeled as white, they take the part that contains the fiber and they remove that. And they leave you with the part that has no nutritional value at all. All right? So things that are whole grain, whole wheat, they contain the fiber. There are fibrous fruits, apples, pears. They contain good sources of fiber, right? A lot of vegetables will have good sources of fiber, right? Fiber is something that's important to make sure you have in your diet, right? Really, 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 really important. So this is like 70, 60% of your diet. Monosaccharides, disaccharides, polysaccharides. What should you have the most out of that group? Mono, di, or polysaccharides? Poly, right? Because polysaccharides are less likely to be converted into body fat because they give you long-term sustained energy that you use instead of storing, right? If you have too much sugar, if you're not using it, then you tend to store it. What time in the day do you think you should have most of your carbs? At night or in the morning?
In the morning.
In the morning.
Ready to go for a long day.
Yeah, because it's going to give you that sustained energy. Carbs at night tend to be stored more. Good. There's one more structural one a lot of people don't know. It's called chitin. Chitin's a kind of a cool molecule. Chitin is found in the exoskeleton of insects. See right here, it's really strong structural. Chitin is also found in fungi, like mushrooms. So chitin is found in insects and mushrooms. We don't see it at all in humans, but it's also a structural polysaccharide. Here you see a good picture of what cellulose looks like, right? And this kind of shows you my point. When you look at cellulose, you're looking at 5 or 6 glucoses put together? No. When you're looking at starch or cellulose, you have hundreds of glucoses glycosidic bonded together. All right, the only difference between that starch and the cellulose is that starch has the alpha bonds, cellulose has the beta bonds. Are we all good? We understand carbs? All right. Next, we have lipids. All right, we already kind of introduced lipids. All right. Lipids are going to have the same function as a carbohydrate. What is the purpose of consuming lipids in our diet? They also provide us with energy. Right? Carbs and lipids both are used for energy. There's a reason why they are both only used for energy. Carbs and lipids are both only made up of 3 elements. What are the 3 elements that you see in both carbs and lipids? Carbon, hydrogen, and oxygen. So if you're looking at carbs and lipids, they're both made up of CHO. That's it, CHO. They have no extra elements in there at all. So they're really great to be broken down for energy. So you know how many calories are in a gram of carbohydrate? Yeah, like 4. 4. So there's 4 calories per gram of carb. How many calories are in a gram of fat? 9. So fat has a lot more energy in it than carbohydrates do. And that is why fat is a really efficient way for us to store energy long term. And that's really what we use fat for, long-term energy storage. Fats are hydrophobic, which means they separate out of water. I actually think I want to stop here and not begin fats. I can't finish it, right? Do you guys feel like you understand carbs? Do you guys like the nutritional stuff is extra. That's not important. You guys appreciate the nutritional tidbits?
It's changing my life so far.
Good. All right. Let's end this here. We'll keep throwing that in because I think it's important for life, like Joe said.